Okay.
Just share that.
There we go. So my name is Bob Roberts. I've worked at Trifecta Technologies for the better half of 5 years now. Most of that time has been spent on Salesforce. Just a quick heads up, this isn't an exhaustive list. If you go into this thinking, oh, I'll just follow these recipes and my app will be faster, you're probably going to be a bit disappointed. It also doesn't include Lightning, because that's a whole new area, or any other third-party JavaScript frameworks. With the quantity that are coming out every single day, I could probably have an entire semester and still not be done. Let's see, it's mostly going to focus on speed as visible to the end user. So this also will exclude things like reports. Workflows factor in, but blazing fast Salesforce code, workflows aren't code. We're going to start off where the user starts off, at the browser. Now, there are many ways to actually measure speed when it comes to the browser. And each browser will have its own tools, and some have additional plugins to do so. Right now, I'm using Firefox, and that's where this screenshot comes from. If I wanted to, I could also use Firebug. If you have Chrome, they have their own utility. I think Microsoft Internet Explorer and Edge have one, but I've never actually found it or looked for it. So these are used to find problems that are outside of Salesforce itself. You can see if the problem is with Salesforce, but it's not going to help you diagnose why. So we're able to see the request from Salesforce, as well as all the other requests that are being made by the browser. So your problem, your page loads up choppy. The first thing you're going to check is in that list of resources that are being loaded up, are there any that are taking a large amount of time or are very large in size? A big problem, no pun intended, a big problem is images that are too large. These can often come from people who don't realize that they should be resizing them before handing them off to you, the developer. And they end up being a huge problem, even if you end up resizing them on the front end. Let's say you have a page of products, 20 of them, all of them taken with a 12 megapixel camera. So nothing absurd. This is actually most mid-range and high-end Android and iPhones will get you, I think, that or greater. You're looking at about 6 megabytes for every image, if it's not resized. So 6 megabytes, 20 images, CSS, JavaScript, the page itself, and everything else that's going to be loading up. You're looking at a huge load time. So what can be done to take care of that? Now, I know it's not always possible, and I know that it's not always within the developer's control, but if a suggestion can be made to whoever has control over those images to resize them to the size that they're going to be displayed on the screen. Resizing them in HTML and CSS doesn't change how big it is when it's downloaded. It'll still download the whole image, no matter what. So if it's resized before it's downloaded, you can save yourself hundreds of megabytes. In my example alone, you would have been downloading 120 megabytes just of product images. I don't care how good your products are, your customers aren't going to wait around for that. There's also large JavaScript and CSS. There's a number of programming techniques that you can use to help reduce these, maybe going through and removing unused portions of your CSS or JavaScript methods that are just unused. There's also a process of minification and concatenation. And what these do, minification, is it will remove any comments. Well, pardon. It'll remove comments except for licensing. It can be set to leave the licensing at the top of the JavaScript file because that's important for legal reasons. But it'll remove almost all the comments. It'll remove the white space. It'll reduce the variable and function names to usually about 1 character long. The same can be said for CSS, minus the variable names. And in fact, I do remember, and I'll put the link up in the notes at the end of the YouTube video, but I do remember someone brilliant and fantastically handsome did a blog post about this not too terribly long ago, working with minification and concatenation and all these sort of static resources with Salesforce, and that'll be posted at the end there. There's also a problem of DOM manipulation, and this is the document object model. This is whenever you're doing things that change the way the page looks, feels, works, acts, whatever, using JavaScript. If it's done correctly, you can have a very nice, moving, fluid, dynamic page. If it's done wrong, though, after the user has seen the page and has started to move around and work on it, the page can start jumping around as elements are hidden, shown, resized, or downloaded. And while this isn't actually a speed problem, it can be jarring. It can feel like the page has slowed down. Moving beyond just the browser itself is the Viewstate. This is the serialized version of your controller, your page, pretty much anything that you have saved on the Salesforce backend that is serialized, transmitted over, and is stored in an incredibly long base64 string in your Visualforce page. You can get insight into this using the Salesforce Developer Toolbar by enabling it on your user. It's actually 2 settings. One is the toolbar itself, and the other is getting the Viewstate tab to show up. And what this does is it'll break the Viewstate down into a sort of hierarchy of folders. You have things like your component tree, and that's pretty self-explanatory. That's the components on the page. Internal and expressions are the various apex tags and the internal representation of the page and expressions on it representatively. And then there's also the controllers themselves, and you'll see that we actually have a breakdown of the controller name, and then this is a variable that's on the controller. It's a list. So it breaks it down into chunks of 20, so you can get all the way down to the various portions of a list to find out what's taking up the most space. Now, there is a practical limit on this. Salesforce will cut you off at a view state of, I think, 135K. But even before that, you're going to want to keep it lower just for the sake of not wanting to transmit that every single time you not only receive the page, but if you post back to Salesforce, all that information is transmitted so it can be deserialized and reconstruct the controller. Now, if your problem is a large view state, there's a number of different possibilities and solutions, and you're going to see these same few items pop up elsewhere in the speech. And that's because a large view state is often, it often coincides with other problems that you might be seeing. So first possibility is that you should mark your variables transient whenever possible. This will prevent them from being serialized and deserialized on the other end. However, it comes with the caveat that if it is needed, if that variable is needed on the postback, then it will need to either be looked up at best, or if the pre-thought, or if it hasn't been thought out well enough, that means that you'll likely get an error where the information is simply not available. Another good tip is to only query up the data that you actually are going to need and use. And this can take the form of using specific where clauses, or just being judicious with lazy loading. Now, if you can't reduce your view state by either transient or just being careful with what you load, there's also the platform cache. Now, the platform cache is very new. I think it just went into general availability this release. Yeah. It's also only on Enterprise Edition or Ultimate Edition, and it can't be used within the controller constructor. And I had problems using it within a lazy loaded variable that was called up from Visualforce. Assuming all those conditions, though, apply to you, this allows you to store any of your information in a nice in-memory cache in Salesforce itself. And this can make for some very fast transmissions and load times. There's two different ways you can go about doing this. Either caching it for an individual user session, and this is great for some of your more user-specific information, more page load-specific information. If, however, you have information that is used across your org, the example that I saw in the docs was a menu bar that was used by everybody. If that information is constantly being requeried by every single user, and it's always going to be the same, then a great technique would be to cache that at the org level, and then everybody can use it. An additional warning should be placed here, though. The cache is not guaranteed. In fact, nothing about this is guaranteed. So you're going to want to have strong exception handling and always have a fallback. You don't want your exception to get handled by simply sending it to the log. That's not going to help your users. Basically, make the assumption that the data is not going to be in there. If it's in there, great. If it's not, though, you're not out of luck because you planned ahead. Finally, take caution with your Apex elements on your Visualforce page. These can increase your view state by adding excess information that you may not need. The big one is usually repeats, data grid, data tables, output tables, anything that might add excessive information to the page. Most of all, in regards to repeats, look out for having repeats within other repeats. Any sins that you commit within this inner repeat is going to be multiplied by however many times the outer repeat is going to get run. If the view state alone hasn't been enough to figure out what the actual problem is, we're going to need bigger. And this is where the developer console comes in. The developer console is an incredibly large suite of tools that can be used to debug exactly where your time is being used in Salesforce. It uses the debug logs. So first off, you have to have the debug logs enabled for whatever user you're trying to figure out. If you're debugging on yourself, I believe the developer console will automatically start up logging for you. But it uses the logs and the timestamp on the logs in order to break down where your time is being used. If you need greater detail in how it's being used, you can simply adjust the log levels from, I think, no logging down to finest and everywhere in between. And this is just a sample. It has an incredibly large amount of information, but for now, we're going to stay focused on the execution log in the top right-hand corner, the execution overview, which is where we're going to see where our time is going, and at the very bottom is the logs themselves. So as you can see here, it breaks it down into Apex code, workflow, database, validation, callout, Visualforce, and system. Clicking on any of the bars will bring up information in the execution log, allowing you a better detail as to what in that bar is being done. Now, I probably should have taken a better screenshot because the execution log is, right now it's loading up a list, so it's doing a lot of just constructors. But were I to click on something like the database, you're going to get what SOQL is being run, how many rows are being returned, information that can help you a little bit better. Now, your problem, slow Apex. Once again, you have to have the right filtering, but As much as you can have filtering in the Apex itself, you can get a data set and then filter through it and only keep the records you want. You're not going to want to do that, because that is time that is not spent wisely, pretty much. SOQL can be incredibly fast with the right set of filters. Therefore, you have to move your filtering into the SOQL itself so you have only the data that you want returned to you reasonably quickly. If you have a situation where you're querying up parents and children or grandchildren, situations where you can't just have subqueries, in that case, you should be using maps in order to keep your data together. Now, in a little bit, I'll have a demo. You'll see exactly what not to do first. And one of the key things to remember is not to make sure you're not looping over your data multiple times. If you can avoid it by putting information into maps, you can save yourself a large chunk of execution time. The maps have to be named appropriately, because what you're going to want to do is you're going to want to have a map with an ID and a S object. The ID is not going to be the ID of the S object. It's going to be the ID of the parent or grandparent that you're linking it up to. That way, later on, when you're going over the parents, it can be referenced simply by calling up this ID rather than by searching through the entire data set of children in order to find the information you want. Also, if you have a large data set and that's it, you need that much data, consider breaking it up into pages. Pagination, along with, I think it's a limit and offset in SOQL, can be used to make a large and very poor user experience a bit more manageable. If none of these are enough, though, if you honestly have to work with a huge amount of data, and perhaps the user isn't going to necessarily see that data, then consider using asynchronous techniques instead. Asynchronous techniques are run outside of the main interaction with the user. They also relax the limits a little bit, allowing you a bit more freedom to work with large amounts of data or large amounts of processing. First up is batch jobs, and these are great for things where you have a tremendous amount of data to go through, and perhaps you can schedule it at a specific time. Batch jobs are perfect for scheduled jobs. And what you can do here is you have a much more relaxed limit. However, you can only have a few of them running at a time. I think it's 5 batch jobs queued up. Anything more than that and you're running into problems. For a bit smaller of limits, but a bit more flexible in usage, is future. Since most of our examples are code that already exists, and I'm assuming that this is all done with improving already existing code. I mean, you can take these examples and apply them ahead of time, but assuming that you're already in existing code, then as long as your methods meet a certain number of criteria, simply adding the @future annotation to the top of a method, and some due diligence, again, a lot of checking to make sure that it's a valid and viable use case. But in those cases, @future can annotate an already existing method. It makes it asynchronous. However, you don't have as much control over it as, say, queuable jobs. Queuable jobs give you more of the control of, say, a batch job. You're given a job ID, so you can monitor it, control it. It's a bit more involved than simply throwing an annotation onto a method. You actually have to make a class up, use the queuable interface. But what you're left with is something with the control of a batch job, with the more flexible usage of a future. Also, as a nice touch, queuable jobs can be started from other queuable jobs. So if you need to chain processing together, that's completely fine. You just can't chain 2 off of a single queuable. Next up, slow Visualforce. This is going to feel a little bit samey both to the apex that I just mentioned and to the view state. But I cannot stress enough, don't do your filtering in the sockle. Doing your filtering in the apex was bad enough, or goodness, do it in the sockle, don't do it in the visual force. Whew. Almost gave some very bad advice. Performing filtering in the visual force is an absolute drain on resources. You can greatly increase your view state. It takes much longer, and it looks a mess. In fact, try not to have much of any conditional logic in the visual force at all. I know that's not possible, and I know that's not possible in all cases, but where it is, try to remove expressions, conditionals. All of that will help reduce the view state and improve the performance. I mentioned before using maps to keep data together, but when it gets down to the visual force level, consider using a wrapper object. Now, a wrapper object or a wrapper class is, well, as its name suggests, a wrapper around a set of data. So what you would do is you'd keep a wrapper of the parent object and then a list of its children objects. That way, when you're looping over them in the visual force, you don't have to check against maps where null keys and, non-existing keys could cause some trouble. Instead, you're left with this self-contained class with only the information you need. Also, avoid loops, and loops, and loops, and loops, and loops. Nothing too new that I haven't harped on already, but I have to say it anyway. If it's not the apex, and it's not the visual force, pretty much the only last remaining chunk of code that we have is our sockle usage, well, our database usage. This includes sockle and DML. And like a broken record, loops, once again, you have to avoid doing things that take a while in loops. Not only is this important for performance, but sockle has both sockle and DML have limits that could easily run out if they're stuck inside of a loop. In fact, you should take a page out of a lot of trigger code handbooks and use bulk techniques. These involve things like going over, say you're querying an object and you're looping over another object to get the key. Instead, loop over the object, get the key, but instead of doing the query directly, put that into a set. Then, afterwards, do the sockle select and pass in that set. What you'll end up with is a small amount of time spent doing this loop and a much smaller amount of time doing the actual sockle. Also, use indexes. Indexes make the performance much better when it comes to sockle queries. You have a whole bunch of natural indexes that come along with any Salesforce object. IDs, this includes master detail and lookups, the name field, as well as some of the system dates. I think the dates are indexed as well. Don't quote me on that, actually. The main ones that you're going to be using are the IDs and the name. You can also add more indexes. The most simple way to do that is by marking fields as external and unique. These need a little bit of pre-planning. If they're used poorly, you can end up with just as bad performance as before. You can also contact Salesforce setting up custom indexes, but that's a little bit outside of the scope of this and would be better off as a conversation between you and your Salesforce rep. There's a number of ways, though, that you can end up messing up your index. Using leading percent wildcards, not equals, and contains all completely throw out the index and ends up kicking you back to a higher cost and lower performing SQL query. In order to determine how your SQL will actually perform, though, we're going to use one more tool, and that is the query plan. Now, the query plan allows you to run a SQL query, and it tells you basically how Salesforce is going to treat it. There's two main ways to take care of this. One is going through anything that can run REST against Salesforce. I mentioned the workbench only because it is the easiest way that I know of. And that'll give you a nice chunk of JSON containing all the information about your queries. If you want to be a little bit more visual, though, you go with the Developer Console. Developer Console has another awesome function when it comes to performance, and that is the query plan tool. So you have to enable, this is another thing you have to enable. So you go into the Developer Console, you go into Preferences, and you enable this. And after you do that, in the tab down at the bottom where you can run a SQL query, you have another option to run the query plan. And what this does is it spits out this little bit of output down at the bottom there. Now, in the example that I have here, I ran a query against a small data set with a external ID. Now, if I wanted to get better results and a much more comprehensive idea of how the query is actually going to run, you're going to want to do this on a large representative data set. So, say production or mirror of production. This isn't modifying data, so you don't have any risk of damaging anything. But always check with your administrator, your higher-ups. Don't go and tell them, Bob told me that I can run queries against production. That's going to get you fired. What it does is it'll tell you whatever fields it's using that are indexed in the field column. In the cardinality, it'll tell you how many rows will be returned for your specific run. It'll tell you what kind of operation it's doing in order to run the query. So index is a good sign. That's usually going to be pretty fast. There's also sharing, if the sharing rules take precedence and return a better data result. Table scan is usually going to be your worst. And this is, quite frankly, just scanning the entire table for the rows that match your where clause. And then there's also the nebulous term of other. And other is things that are done inside of Salesforce, inside of their black box, that could return a better result, better speed, but it's not explained further as to what that actually is. So the cost column is perhaps the most important one on here. Well, that and cardinality. If you expect it to return one result and it returns 25, 100, 200, perhaps speed isn't what you should be looking at, and making sure you're getting the right data is. Other than that, though, you always want your cost to be under 1. In this case, the index gives me an incredibly low cost. Table scan gives me a low cost. Now, if I had a much larger data set, and this is where that representative data comes from, if I had a much larger data set, the table scan could exceed 1, in which case you're likely to run into either slow performance at best, or there's also a limit, non-selective queries. So the one is going to aggravate your users, the other one's going to get you a talking to. S-object cardinality is just however many objects that are actually in that total data set, and then what object you're running it against. Demo time. So let me just head on over here. One of these contains, not that one, that one. Let me just blow that up. So now we're going to look at some poorly running pages. This one here, I called it Accounts version 1. I have my Viewstate all set up here. I'm also going to turn on the Firefox developer tools. Now I have 2 toolbars. I can make this look really ridiculous. So what I'm going to do is I'm going to do a shift refresh, and that is so that none of the cache matters. It is going from the very base. I'm going to keep an eye on my network tab here.
It's just the Wi-Fi.
Mm-hmm.
You're a developer, right? It's always the Wi-Fi.
Yeah. No, this page was custom made to be as terrible as humanly possible.
Did a good job.
It's gonna keep on loading and loading. In test, I've seen this take about 70 seconds. So if you want, maybe do some arm stretches, stand up for a moment. And this is basically taking everything that I've talked about and doing the opposite. Okay, came back. Let's see, there we go. Oh, it came back faster this time at only 41 seconds. So the information we can glean from this, heading into timings here, is that we spent no time or a trivial amount of time doing all the setup for the actual connection and a whole lot of time waiting. If we saw a large receiving, that would mean that we're sending too much data. We have either too complex of HTML or an oversized view state. Because it's spending most of the time actually waiting, though, we can glean that it's doing something in the processing stages. We're not sure yet, but this is just a first look. We can also check out the view state. And the view state is 28K. It's not great, but it's not that bad. Especially for the data that we're showing, it's really not that great. So let's drop that back down. As you can see, it took 41 seconds just to build up this table of data, which your users would probably be very disappointed in attempting to use. We're going to take a look at I'll start easy, the controller. The controller has fewer sins, but they're still there. So we have a few lazy load properties. This one gets accounts. It only gets 98 of them because if I had any more, I hit a SOCL limit.
Is there any way you could zoom in a little bit?
Don't know. Yeah, there we go. Better?
Much better.
People in the back? Okay. As I was saying, we have a few lazy loaded properties. We get the parent, we get a child, and here's the first sin of the night. We have a for loop looping over all the accounts and grabbing the children like this. So we're adding these to a list. This is a terrible, terrible practice. So the nice thing about it is, though, is that it's very easily recognizable and it throws up red flags that perhaps you should be on the lookout for other problems. And then we get another child, a child of contacts. This one, because I wanted to have a nice, large, slow page, I had to cheat a little bit and make this not as bad. Otherwise, I'd hit a SOCL limit. So this one actually is using the correct bit of bulkifying. I'm grabbing the IDs, and then I'm running the query against them. I still have to limit it to 50, though, because in my testing, I noticed if I had too many more than 50, I ended up hitting a limit I've never even heard of, where I had too many objects on the page. I had never seen it before, and I hope never to see it since. So bad stuff here, but not as bad as the Visualforce page. Here's where we get in the juicy bad stuff. We have a data table, which in and of itself, possible smell, but not too bad. Then we have the apex repeat. And what it's going to do is it's going to loop over every single contact that we got for every single account. And in my initial data setup, I had 10 contacts per account. So we searched up 98 accounts, 10 contacts per account. That's not that good at all. So we're going to loop over all the accounts or all the contacts for every account. And then we're going to be doing this conditional bit of rendering here in order to either display or pass over that particular contact. Then to add more, I do another repeat. So now for every, for every contact organization, that's a child on contact. So what ends up happening is for every single account, I'm going to loop over every single contact, which is going to loop over every single contact organization. And this is the magic of how you get a 41-second table. And then I just spit out some information. So right here, we see a clear path of optimization. So we're going to back out this. We're going to move on to accounts version 2. Now this one's still going to take unnecessarily long, but as you can see, it is much quicker than the other one, at least. That gets you a gold star. So now I've dropped it down to, I've dropped it by a whole 90%. We're down to 4.1 seconds. It's better. People probably won't complain as much, but in the back of your mind, you'll know you really could have done better. Head into accounts version 2. Same thing over here. We're going to preload this one. Now here we see that we have we now have one major property, and that's the wrappers. And this is made up of account wrappers. Account wrapper is just a thin class around an account, and a contact wrapper, and you can probably discern what the contact wrapper is from the name alone. So we end up doing our queries. I've kept the queries as similar as possible to the last one to try and minimize the amount of things that I'm changing from one example to the next. So the queries are pretty much just as bad. I'm still doing SOC1 in a loop here, so bad on me there. But just by removing the for loops from the Visualforce, that alone netted me a 90% savings. So now what I'm doing is I'm taking the accounts, I'm getting the contacts together in, let's see, where are they? Okay, right, that's the next one. Sorry. I'm going through the accounts, I'm going through every contact again, and I'm going through every contact organization. So I'm still making just as many loops, but by moving it from the Visualforce to the Apex, that alone gave me a great gain in speed. Visualforce page hasn't changed too much. It's now referencing the wrapper instead of the direct properties. However, while we still have these nested repeats, we no longer have the conditional logic filtering out information. Backing out, and now off to version 3. Okay, let's see how long that one took. That one dropped us to 3.8, so a much more modest gain. But what ends up happening is that your code's going to be cleaner, there's going to be less loops, you're not going to hit the limit as quickly, and let's see how we achieve that. So here, pretty much same as before, except now we're doing a number of small changes. I've bulked up how we're searching up the contacts. This one, I am doing a loop to build up the set of IDs, but that's because I'm already making up this map here of contacts to parent ID. Doing pretty much the same thing with the contact organizations, going through and building up a map of those to their parent ID. And now, look how much nicer and neater that is. Now I'm only going through and using get on the map. I'm getting just the data that I need. I've only looped over the entire set of contacts once. I've only looped over the entire set of contact organizations once. And then in the end, I'm going to end up looping over the contacts twice when you add up all the micro iterations here. But I only do one major loop over all the contacts, and then I loop over the individual ones. So that's cut down on the amount of iterations. You're going to have cleaner debug logs as a result of that as well. And the visual first page has remained actually exactly the same. So that just about wraps up what I can show you with the demo. Does anybody have any questions?
I have a question on viewing the Viewstate.
Mm-hmm.
As you do postbacks, does the Viewstate keep refreshed so that you can see changes? So if you added records to your list or records from your list?
I have seen the Viewstate change with post. Now I'm not sure about your specific example.
So if you were to re-render a section,
I have re-rendered a section, yes, and the Viewstate did change. Mm-hmm. Anyone else? All right.
Can I add a tip?
Sure.
One of the things that sometimes is maybe thought of limited to partners, especially partners on the ISV side, is there's a tool called the Force.com security scanner.
Mm-hmm.
You can search for that, where you can go and submit the credentials to your organization, and it'll run through and it'll evaluate your application against security issues, but it also will do a code quality analysis. So it'll tell you if you have sockle and for loops, if you're returning queries without limits. So a nice little tool where you can get some feedback. Sometimes you do have to be cognizant of false positives around tests and test classes, but a way where you can have check marks, security kind of go through and run evaluation against your code. But it's something that everyone could use if they want to.
And what was the name of that again?
The Force.com security scanner.
So the Force.com security scanner.
Yep.
And that is a good point to mention about false positives, is that with any static analysis tool, you got to use your brain. The tool can't take over, but it can definitely give you hints. It can leave you trails to find these potential problems. Any other questions?
I have a tip too, I guess. I was thinking about the query plan tool. So recently talking to Chris Peterson about this, actually helped build that tool. So that cost that you have there, that number that you said was really important. It's actually a not well-documented limit, but if you have a table with over 100,000 records in it, just say you have an account, and it doesn't matter what you're really doing, but you have 100,000 accounts in your system. If you have any queries to an account as part of any trigger code in your org, that query has to be selective or it'll throw an exception that's uncatchable. So it's something you don't really notice until you have, and there's a really good point of, wait, if you're going to test this stuff, test it against these large things, because the indexes and stuff have actually different values of what you need to be selective. So if you're working up to like 1 million rows, so you're querying 1 million accounts, right? Or querying, there's 1 million accounts when you're querying. Your selectivity will be different than if you're querying like 5 million. So you need to filter it down to a smaller data set as that number continues to grow. So if you ever run into anything really weird when you're dealing with these really large data sets, it's definitely good to look at that tool, because that'll be by far the best way to improve your performance.
Yep, and like you said, the cost is how you determine selectivity. Below 1, you're golden. You have a selective query. Above 1, you have a non-selective query, and you could run into that exception. Yes.
Earlier you mentioned about the platform cache
Mhm.
being a good thing to kind of speed things up.
Yes.
Is that caching on Salesforce side? Is it like doing like an in-memory cache, or is that a browser cache and it's like doing a local storage cache?
That is a Salesforce cache.
Okay, so it's caching so you're saving on like database queries and stuff like that.
Yes, and I suppose if you get into a bit of deep JavaScript, you could use some local storage to cache things in the browser, but that's beyond the scope of this.
So I had a question that might also be a little beyond the scope.
Go for it.
With the visual force and the apex and the looping and all that stuff, it almost seems like it would be better to just go the JavaScript route and just avoid visual force altogether. Like, you would get rid of all that stuff. You would have a more responsive page. You could have pop up and then just have your data slide in whenever. I mean, is there a reason why you wouldn't head down that path?
I think there's always going to be a use case for visual force, but I think that is sort of the direction that they want to take with Lightning. I know that there's also, I can't remember the name of the project, but a way of implementing Angular specifically in Salesforce. Anyone know that project name?
NG-Force.
NG-Force, that's it. So yeah, it's beyond the scope to try and figure out what the performance benefits and detriments are for third-party frameworks, because if you keep your ear to the ground, there's a new framework probably in the time that I've been talking about this. So JavaScript frameworks are a dime a dozen. Use the one that you know best, and if you can get a demonstrable performance increase by going with that route over, say, Visual Force, then perhaps make a case to your manager.
Yeah, I think that's ultimately what it comes down to is speed of development, right? Because you're going to be able to build a Visual Force page a lot faster than you could like an Angular page using Visual Force remoting and things.
Mm-hmm. Yeah, so you have to demonstrate that whatever cost there is in making up the page, in setting up all this JavaScript, getting the views ready, that cost can offset the speed benefit, or pardon, the speed benefit can offset the cost. Final questions? No? All right then. Thank you very much.